Since the very first humans lifted their eyes to the stars, one question has followed us through every age. How big is this place we call home? Each generation felt closer to the answer, and each time, the universe proved us wrong. Then, in just its first year, the Webb telescope did something no tool in human history had ever done. It didn't just look at the universe, it pulled back its curtain. Webb showed us stars being born behind thick veils of cosmic dust, galaxies slowly crashing into each other like giants in a silent, slow-motion dance, and deep space views so crowded with galaxies they make your brain stumble trying to count them. And just when we thought that was the peak, Webb went even further. It delivered one single, breathtaking image, a massive cosmic map so rich, so packed with structure, that it's now forcing scientists to rethink how the universe itself grew up. This is the Cosmos Webb field, the largest, deepest, most detailed portrait of the universe ever made. And what it shows is unsettling. Because the early universe wasn't empty. It wasn't quiet. It wasn't waiting patiently to become something. It was already alive. To really feel why this changes everything, let's rewind for a moment. For years, our best window into the cosmos was the Hubble Space Telescope. Back in 2004, Hubble stared at what looked like a tiny, boring patch of black sky for 11 straight days. When the image came back, the world was stunned. That empty darkness was bursting with around 10,000 galaxies, each one holding billions of stars. Some of that light had been traveling toward us for more than 13 billion years. The Hubble Ultra Deep Field became legendary. It rewrote our estimates of the universe, pushing the number of galaxies into the trillions. But even Hubble had its limits. It mostly saw invisible light. And here's the catch. The farther back in time you look, the more the universe stretches that light into infrared. Light Hubble simply couldn't see. That's where Webb steps in. With its giant golden mirror and powerful infrared eyes, Webb doesn't just look deeper, it looks through dust, through time, through entire cosmic chapters that were once completely hidden. And when Webb finally opened its eyes, it didn't gently improve Hubble's picture, it shattered it. Picture this. If the Hubble Ultra Deep Field were printed on a single sheet of paper, the Cosmos Webb image, at the same detail, would stretch across a wall more than 13 feet wide. Not a zoomed-in snapshot, a continuous, connected map of the universe. This isn't one long stare into a tiny patch of darkness, it's a sweeping survey of the sky, covering an area about 3 times the size of the full moon. To create it, Webb spent over 250 hours collecting thousands of images, then weaving them together into one seamless cosmic tapestry. The result? More than 780,000 galaxies, all in a single frame. This one image spans nearly the entire story of the universe, from just a few 100 million years after the Big Bang all the way to today. For the first time, scientists can follow how galaxies grow and change across cosmic history without jumping between broken pieces. It's the difference between seeing one street and suddenly seeing the entire city, its neighborhoods, and the highways that connect them. And this is where the real surprise hits. Because you're not just looking at a picture, you're looking through time. Even the galaxies that feel nearby in this image aren't really nearby at all. We're seeing them as they were billions of years ago. They already look mature, shaped, and often locked in graceful gravitational dances with their neighbors. Across this enormous view, galaxies don't sit randomly. They gather along invisible threads, forming a vast, ghostly framework scientists call the cosmic web, the hidden skeleton of the universe itself. And tucked inside this same sweeping map, astronomers stumbled on something truly strange. 2 galaxies caught in a slow, intimate collision, twisted into a shape so beautiful it earned the nickname the Infinity Galaxy. But the real shock isn't just the shape. Between the 2 galaxies, not in the heart of either one, appears to be a supermassive black hole, floating in the space between them. If that's confirmed, it hints at a brand new way black holes might be born. A quiet reminder that when you look at enough of the universe at once, The rare, fleeting, almost impossible moments finally step into the light. That's exactly what Cosmos Webb was built to reveal. Now, as we drift deeper into the image, we're not just moving across space, we're sliding back through time. We enter an era astronomers call cosmic noon, about 10 billion years ago, when the universe was in its wild, energetic prime. This was the age of fireworks. Galaxies were churning out newborn stars at a furious pace, fueled by massive rivers of gas. And yet, Webb finds things that shouldn't be there. Some galaxies already look tired, quiet, dormant, as if they've burned through their fuel far earlier than expected. Others show elegant spiral arms and neat, ordered shapes just a few billion years after the Big Bang. According to everything we thought we knew, galaxies weren't supposed to look this organized so soon. Gravity, chaos, and constant collisions were meant to keep them messy for ages. But the universe, apparently, didn't read the rulebook. Changes that should have taken billions of years seem to have happened in what feels like a cosmic heartbeat. And the deeper we go, the more dramatic it becomes, until we reach the very edge of what we once thought was possible, the cosmic dawn. This is the era only a few 100 million years after the Big Bang, when the very first galaxies were expected to appear as faint, fragile smudges of light. Before Webb, scientists believed bright galaxies at this distance would be incredibly rare. They were wrong. Webb keeps finding them. Again and again, records fall. Galaxies like JWST, seen as it was just 290 million years after the universe was born, and MOM Z14, glowing brightly only 280 million years after the beginning of everything. These aren't weak, half-formed prototypes. They're bright, massive, chemically rich. They already contain elements like carbon and nitrogen, which means earlier generations of stars must have lived and died before them, in what feels like an impossibly short window of time. In cosmic terms, the universe didn't grow up slowly, it grew up fast. Too fast for our current theories to comfortably explain. And that's why Cosmos Webb matters so much. It doesn't just show us stunning objects, it hands us a problem we can't ignore. The early universe looks more crowded, more structured, more mature than we ever predicted. Maybe galaxies formed earlier. Maybe black holes grow faster. Maybe there are entire processes at work that we haven't even imagined yet. So astronomers are going back to the drawing board, not because Webb failed, but because it worked too well. This single image answered some questions and exploded 100 more into existence. And that's how scientific revolutions begin. So what is the true scale of the universe as Webb reveals it? It's not just measured in light years, it's measured in realization. The realization that a tiny patch of sky can hold hundreds of thousands of galaxies. That the early universe wasn't a quiet, gentle beginning, but a roaring, chaotic, creative storm of structure and light. That even our most confident cosmic timelines were only rough sketches. We are the first generation to see the universe like this. And maybe the most humbling thought of all is this. This breathtaking map, the largest ever made, is still just one small window. Beyond it, there are countless more. The universe is bigger, deeper, and stranger than we ever dreamed. And for the first time, we're finally starting to see it.